Assalamualaikum warahmatullahi wabarakatuh.
Okay, guys. Today we will continue our lectures for today. Right? How are you guys? Have you eaten? Dennis. Okay. Right. So next week we will have a class on Sunday, right? And on Thursday, I think we will not have the class on that day. I think lah. Alright, but I will confirm with you later on next week. Okay, alright. For the test one, right? The result is not. That's mean I did not get it the result yet because they are still marking the other lectures still marking about your test one. All right, and I hope that we can get it by next week maybe. All right. Okay. Okay. For today, what we going to learn, right? So I have issue the frequency analysis, all right, and then for today what we're going to achieve is we're going to draw, all right, the locus of the frequency analysis by using the Nyquist diagram. So I hope that you already print out the Nyquist diagram. Right here is the Nyquist diagram. So we're going to draw our we call it Nyquist plot. Okay, right in here. Okay, so everybody, you have print out all this one, right? All this Nyquist diagram, right? This one we call it polar plot, right? Okay. All right, good, Jamquet. So maybe after this you can share on what you have drawn on this polar plot. All right. Okay, so you can screen my screen, right? Good, thank you. Example 5.1. So this is what we have been done on last Sunday. All right, example 5.1. If you want to draw the polar plot, right, or Nyquist diagram, so first of all you need to find the open loop transfer function, which is the KGH here. So by looking at the block diagram, right, on example 5.1, you only can see the gain and tangent, and there is no feedback, right? So we assume that K and H is equal to 1, right? So from this one, what you can get it is you get it is 8 over 2 plus S and 4 plus S, right? However, we try to make it like first order equation, right? Which is 1 over 1 plus Ts. So we want to make it like Ts, right? Here. And then you need to factorize. So after that, we got it is 1 plus 0.5 S and 1 plus 0.25 S here. Okay, so this is we'll make it like this format, right? Ts here. Okay, so why we need to have this one from this one, what we can found it is omega means that's mean 1 divided with T max. Okay, and also we can found it omega max equal to 1 over T means. Okay, so this is what we going to got it from equation here. So T max, that's mean the value that be higher is 0.5. Okay, so 1 divided with 0.5, then we got it is 2 radian, right? Okay, 2, right, 2 radian per second. And this one 1 divided with T mean 0.25, then we got it is 4 radian per second. Okay, all right. Why we need this value? Because we're going to plot omega from 0 to infinity. Okay, so we're going to plot omega here, and then there is again here. Um, I put it kgh. Okay, alright. Or maybe you can put g also. It also can. And this one I can put it uh, uh, p. Alright. The symbol is p. This is the phase angle, and I put it a more column. This is real. So why I put it like this one? So I will explain it to you. Okay. Right. Now we're going to see the omega from 0 until to infinity here. And but this one is only our for our guideline 2 and 4. So we can put it 2 here, and we can put it 4 here. Okay. Right. So this is the magnitude, and this is the phase angle, and this is the real phase angle that you're going to plot. Alright. So why I put it like this one, I will explain it later. Okay. So this one clear? Do you have any question? Alright. For those maybe last Sunday not join to the class, so maybe you have any question? Ada apa-apa soalan hari ni? Tak ada? No? No question? Okay. No. Alright. Thank you. Alright. Now, actually for this question, you can just get it only kgh here, right? And then you can straight away use your calculator to get all this value. Alright. However, if your value in this table is wrong, then you will lose total of mark, right? You will lose a lot of mark here. So what you can do is you try to get it in term of number 2. So again here kgh, right? Right. So when you apply JW, right? So 1 plus 0.5 JW. This one the kgh first, and then 1 plus 0.25 JW. Okay. Right. And then you want to find the magnitude. Okay. That's me 1 over square root 1 squared plus 0.5 omega squared, and then square root 1 plus 0.25 omega squared. Okay. Alright. So try to find out like the equation like this one lah. Alright. Okay. And then you can find the phase angle. Alright. So that's mean minus inverse tangent 0.5 omega divided by 1, and minus with inverse tangent 0.25 omega divided by 1. Okay. Alright. So you got this kind of question. So what I'm going to show you, if your table is correct, it's fine. You can get a full mark there, right? But it depends on your graph lah. Okay. However, if you got it wrong with this value, right, in this table, so you will lose this mark, right? You will lose this mark. So my advice is maybe you can come out with this equation also, all right? And also the equation of phase angle. Good. Do you know what I mean? Faham kan? Okay. Good. So now I'm going to show how can we use the what we call it, the calculator, right? The calculator. So first of all, we're going to develop this one, right? To develop this one. Okay. So this is your calculator. So first of all, you can choose the fraction, and 1 you divide with parenthesis 1 plus 0.5, and a is the unknown, okay, variable. We time with 1 plus 0.25 AI. Okay, here. So I will write it here. Okay, so you're going to put like in your calculator 1 plus 0.5 AI, 1 plus 0.25 AI here. Okay. Right. Okay. Do you have any question about how to use this calculator? Ada apa-apa soalan tak? Macam mana nak guna calculator? Everybody got it, right?
Tak ada soalan saya.
Tak ada? Okay, good. So maybe you can proceed. So everybody tak sabar how to plot. Okay. So I will show. Hopefully you can see that, right? Okay. So this is the maximum that I can zoom in. Right. So now you can calculate. So for example, the value that we want to plot now is a 0, right? So sometimes you cannot put a 0 because it will give you some infinity, right? So why not you put a 0.0001, for example. So now you got it, the magnitude is equal to 1. The magnitude equal to 1 here, and then the phase angle is minus 4.29. So that means it will going to 0. Okay, so that's why in this one, for phase angle equal to for the frequency equal to 0, so we can say that the magnitude is equal to 1, and this one is almost 0 degree. Okay, then you can repeat for the phase for the frequency equal to 2, calculate, and then you can put a 2 equal, then you can get a 0.632. Okay, here 0.632, and then this one is minus 71 degree. Okay, be done, and then you put it, calculate, equal to 4, then you got it 0.316, and then this angle is minus 10. Okay, so this is how you calculate by using your calculator. Okay, so now we proceed to here. So you got it, all this value when you look at the table that I show it to you. Okay, so why at this another column I have the P real, right? Because sometimes when you got it is positive, right? Maybe you using your calculator, you got it a positive 108. So this one you need to minus 360 minus with 108. For example, okay. Wait for minutes. I think you need to minus with 306 so that you can get it negative also. Okay. Yeah. This one you will got it positive. So 108.4 degree you minus with 360 degree. Yep. So that we can get it all is negative. Alright. If you don't have this column, that means when you want to plot it, so you will think, why I got it positive, and then you make it all negative. So it is wrong. Okay. So that's why I make it another column here. Right. In this example, yep, it should be okay because all you got it is negative. Right. So it's good. Okay. So far, do you have any question about this one? Ada apa-apa soalan tak before we can move to plot the Nyquist diagram? Ada apa soalan? Okay, so are you ready to plot the graph? Dah ready dah? Dah ke belum? Dah, sudah. Okay, good. So, first of all, let's look the graph. Okay. I can't zoom it. Okay. Never mind. So I need to open the slide here. 5. Yeah, example 5 for now. Maybe I can zoom it from here. Okay. Yep. You will see that this is, we call it polar plot. Yeah. Okay. In this polar plot, right, there is a 0 degree and then it will increase 10 degree, 20, 30. Okay. So, and then there is a line from this one, right? This major tick, we call it major tick, right? To this one, it will be divided with 10, right? That means this line is 1 degree, 2 degree, 3 degree, 4 degree, and so on. Okay. All right. And then you will have another this like circle here, circle, and so on, right? So the tick between this one is also divided by 10 also. That means this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. So how we're going to use this is this circle, right? The circle that's mean it represent you the magnitude. Okay. And the line here is represent you the angle. Okay. Right, good. So let's plot our first graph, Nyquist diagram. So first of all, you need to look at the value. All right. So what is the maximum value? Okay, the maximum value is 1, right? Okay, is equal to 1. All right, that's mean in your graph here, if I hope that you can see that. Okay. Boleh saya cubalah yang mana. Okay. Alright. Okay. So first of all, you need to start with 0 degree to 360 degree. Okay. You will see here. So this is your title. Mesti to measure here. So 0 degree to 360 degree. Okay. So next is the maximum is 1, right? So what you can do is you can calculate here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is 9 circle, right? Until here. Okay. So let me choose that. I want to choose it this one. So I put it 1. Okay. Boleh ikut ada kalau laju sangat boleh suruh saya ulang balik. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So I put it 1. Okay. And then this one is of course 0. Okay. Yang lain tengah buat ke?
Yes, Doctor.
Okay, good. Now, 1, 2, 3, 4, 5, 6, 7, 8. So that's mean 1 divide with 8. So 0.125. That's mean for this one it will be 0.125. Okay. And this one will be times by 2, 0.25. Okay, and then you time by through 0.375 and so on lah. Okay, we try to calculate it, right? And 1 minus 0.25, so this one will be 0.875. Okay, right? Yep, in this example. Okay, so maybe I can give it to you, the example. I will give it to WhatsApp. You can view it now. You can zoom it. Okay. Alright. Okay, I already share to this group WhatsApp. Okay. Alright. So you already got 0.7, 0.875, 0.75 here. Okay, 0.75 and so on. Alright. So let's proceed. Where's my... Okay, done. Alright. Okay, so we're going to plot the first point at the omega equal to 0. So the magnitude, we got it 1. So the magnitude is here, right? 0 until 1 here. So we got it, the first plot, which is here. So you just make some cross here. So this one is omega equal to 0. Okay. So the magnitude is 1, right? Okay, done. And then the omega equal to 0.5. All right. The magnitude is 0.693. Okay, and then the angle is minus 21.1. Okay, all right. So 0.963, how you going to plot it in your graph here? All right. So that is one method how to calculate the step. All right. So how to calculate the step is simple. You take it as 0.963, you minus with 0.963 is between 0.875 until 1, right? So we take it the minimum 0.875, then you divide it into the small tick, all right? So 0.25 divided with 10, so it equal to 0.0125. Okay, so this one you can calculate 0.963 minus with 0.875 divided with 0.0125. So you got it is 7.04. So that means 7 step. Okay, 7 step. Okay, that means so start from 0.875. So you need to calculate the that means 7 step or 7 box. Okay, 1, 2, 3, 4, 5, 6, 7 here. Okay, so maybe I can show you this one. Okay, so what I got it is 6.8. Yeah. Okay, so this one is like a 7 step. So what you can do is 0.75, 1, 2, 3, 4, 5, 6, 7. Right? This value is 0.96. Okay. Boleh ikut tak? Boleh tak? Nampak tak? Is it okay? Okay,
Okay,
good.
sir.
Okay, good. Now we already got it the gain, right? The magnitude. So now we're going to find out the angle. So angle is minus 21. Okay, minus 21. That means you start from 0 here. Can't see that. Sorry. it start from 0 here, and then after that is 10 degree, after that is 20, so 20.1 is like this one, okay, 21.1. So you need to bring your magnitude here, bring, and then you will see that, yeah, is there. So this one is omega equal to 0.5. Maybe I can show this one. Okay, 21 here, right? 21 is here. 21 is here. 21. Okay, and then you bring it here using your ruler. Okay, this one is 21, and this one 7. Okay, 7 step. You bring it here, and then you will found it. Yeah, if let's meet that this one. Okay. Okay, boleh? Boleh ya? So far, so good. Okay. Alright, done. Okay. Then you can continue to calculate omega equal to 2, omega equal to 3, omega equal to 4, and omega equal to 10. Okay. So let's do this together. Done. Equal to 5, equal to 2. That's mean 0.632 minus with 0.62 in between. 0.75, 0.625, and then 0.5 here. Okay, so that's mean for 0.632 you minus with 0.625 divided with 0.0125. So it's almost half step, right? So we can say that 0.62 here lah. Okay, half step. So what the degree is 71, 50, 40, 50, 60, 70. Yep, 71 here. Then you bring it 71. Okay, done. So this one we got it is omega equal to what is it? Equal to 2. Okay, done. Okay, and then 3 0.4443, so 0.443 minus with 0.375 because it's in between this one divided with 0.0125. So 5 step, 5 box. 1, 2, 3, 4, 5. Yep.
Why we divide over 0.0125?
Yep, because 0 until 0.125, that is 10 box. Do you understand? 0 until 0.125, there is 10 box. That is 10 minor tick. Do you got it? Do you got it? Okay.
Okay.
You got it. Okay. So here to here, that is 10 box or 10 minor tick, right? 1, 2, 3, 4, 5, 6 until 10. Okay. Right.
Okay.
So I show you this formula, right? In order to find how many box, right, or how many tick, right? Minor tick. Okay. Good. Right. And now where am I? W omega equal to 3. Here we take some time here. 0.44. So it will 0.44. It will take about 5. 1, 2, 3, 4, 5 here. Okay. And then what is the angle? 93.2. 80, 93. So 1, 2, 3 here. Okay. And then this one. 1, 2, 3 here, down, okay, this one. 1, 2, 4, done. Done here. Omega equal to 3. Alright. And then 0.316, so in between 0.25 until 0.375 here. So you can calculate 0.316 minus with 0.25 divided with 0.0125. So it's also require 5 stops. 1, 2, 3, 4, 5 here. And then the angle is 108, 19, 100, and this one 9 and 8 here. Okay. One, two, three, four, five. Yeah. Okay, so this one is omega equal to 4, and omega equal to 10 is almost 0 here. So minus 146. 146. Yep, you can say like this one. So this one is omega equal to 10. Now we already got it 1, 2, 3, 4, 5, 6. So how to draw it is needs a sum curve, and then yeah, this is your Nyquist diagram here. Okay, so I think I can show you the detail like this one. Okay, yeah. Alright, are you done? Dah siap dah?
With the bro.
Okay, maybe you can share on the WhatsApp group. Okay, maybe we can. Alright, anybody who going to share? Yeah, Natif, good. So let's see. Okay, download. Alright, open it. Alright, this is have been done by your friends. Nakib, Al-Haddad, good. Alright, so let's rotate. How to rotate? Okay. Okay. Yeah, just this one. Okay. Okay, good. Alright, so this is what have been done by your friends. Good. Okay, so you calculate the step and so on. Good. Alright, so this is our Nyquist diagram. Very good. James quite good. Alright, you also have share your drawing. That means you already done in class. Yep, this is what have been done by your friend. Okay, good. Very good. Okay, actually you can choose one. You can start at 7 here, or maybe 6 here. All right, or maybe you can start one at 9 here. All right. Okay, Good. Alright, do you have any question? Ada apa soalan? How to plot? Do you have any question? Good. Nakid and Jem no sir. Good. Alright. Now for today also we're going to know from this kind of graph, right? From this kind of Nyquist diagram, how can we know whether our system is stable or not, right? So from this graph, so we can know that, all right? Okay, so this is done. So let's proceed for others example. Okay, yep, example 5.2 here. So you are given a block diagram k equal to 1, okay, and then gain g and h here 1, right? Then you find out the kgh, the open loop transfer function. So you already got it here, right? K times g times h, all right? And then my advice is you come out with the gain here for the when you replace s equal to jw. So you come out with this one, and from this one you can find out the minimum t, right? So in order to find the maximum omega, and for t max you can find the minimum omega. So this is your cut line, right? 5 and 20. Okay, so let me share. Right. So we zoom out again. Okay, where is it? Right. Now we got it is here. Okay. Our kgh, right? Example 5.2, our kgh is equal to 10 divided with s1 plus 0.2 s, then you time with 1 plus 0.05 s. Right, maybe for the rest, if you want to share on how you plot it, yep, maybe you can share in the WhatsApp group, so maybe your friend can see that. Okay. All right, done. And this one we can get it is 0.2 and 0.05. That means this one is t min, so this one is t max. Okay, and then from this one we can find out omega mean 1 or divided with 0.2, and this one omega max 1 divided with 0.05. Okay, so from this one you get it is 5, and this one is 20. Okay, then you start to have a table here. Omega start from 0 until infinity, and this one the magnitude kgh, and this one the p, and this one is real. So you have got it 5 and 20 in between. So before that maybe you can choose a 10, all right? 5 before that maybe you can choose 2, for example, right? If you want to get accurate plot, so maybe you can choose more value, for example 7. Okay, so this one is 30, for example. Okay, so now you can start use your calculator here. So what you have is 10 divided with s will be your AI. AI you time with 1 plus 0.2, AI here plus with 1 plus 0.05, AI here, Okay, so you already okay. So this one, this is what you're going to put it here. Okay, alright. Okay, then you can press the calculate here. Calculate. Now omega equal to 0. Omega equal to 0. So when you try to put omega equal to 0, that means you got some error. So why not we put it 0.0001, okay, and equal. So you find it, you can find that 99,000, right? Okay, and then the angle is minus 90. So that's mean this one when omega equal to 0 is infinity, and this one is minus 90. So real also minus 90. Okay, you got a negative and negative. Yep, it's also fine. Good. And then you calculate it again. Calculate equal to 2. So 4.62. 4.62. Then the angle is minus 117. Okay, good. Calculate equal to 5. So 1.37. Then the angle is minus 149 degree. Right? And then calculate again. Go to 10. Yeah, you got it 2/5. 0.4 and minus 180. Okay, good. Calculate again. Go to 10. Yeah, equal to 10 here. Okay. Calculate again equal to 20. Yeah, when you put it in 20, right? When you put it 20, what you got it from your calculator is 0.08, right? 0.08. However, the pace, right? The pace angle you got it is plus 149. Okay, right. That is why I put it. Yeah, that is why I put it is another column here. Okay, right. So the minus one you maintain, right? 149 degree minus 180 degree. So this one you need to minus with 360. So 149 minus with 360 degree. So now you got it is around how much is it? 210, right? Minus 210.
Sir, why do we have to minus 360?
Yeah.
Why do we have to minus by 360?
Yeah, because we going to maintain all is negative.
All right. Thank you.
Okay, good. Right. So if you got it positive, right? So after you going to plot it, you will try to find 149, yeah, positive here. So it will be wrong. So it will be like the same direction. Okay. So 0 degree here, it will be minus 10 degree, minus 20 degree, minus 30 degree, and so on. Okay. All right, Dafa. All right.
All right. Thank you.
Okay, good. And then you can proceed 30 if you want it. How about infinity? How you going to put the infinity value in this one? You just press calculate. Right? Oh, lah. I already delete it. Okay, you just calculate an infinity value. You just put it around 19,000, for example. Then you got it is 0 here, and then is 270 here. Okay, minus 270. Alright. So this is the infinity value. And then after that, you start to plot your graph. Okay. So maybe I can show to this one 5.2 here. Rotate clockwise, rotate again. Yeah, you got this kind of graph. Okay, so of course the infinity, that's mean the value for infinity is equal to 0. Yep, omega equal to infinity, right? The value is equal to 0 here. Okay, all right. And then omega equal to 10 here, 0.4. Okay, not much. Then equal to 5, 1.327. Okay, equal to 2. The magnitude is 4.619. Okay, because a maximum is 5. Okay, here. Okay, so 4.6 that means 4.3 here. Okay, so you can calculate the how many box or how many step here. So 1 2 3 4 5 4. Okay, here, and then you withdraw it 4 here, withdraw. Okay, until here. So but you need to look at the angle is minus 117. So 117. Oh, it should be around here. Yep. Yeah, some mistake there. Okay, 100. This one is 1110. So it should be like this one. Okay, alright guys. Okay, alright. And then after that, omega equal to 5, and then you got it 149 here, 140, 150. So 149 here. Okay, this one, this one. Then you will draw a curve, right? So you got it this kind of graph. Okay, good. Do you have any question? Is it clear? Clear? Before we can proceed, how we going to see the stability? Okay, boleh? Boleh Okay, this is how you draw the Nyquist diagram. Nyquist diagram will be asked during the exam, final exam, and total mark will be 10 marks. Okay, okay. Can I proceed? Boleh? Sekejap sir, yang infinity macam mana tadi nak dapat magnitude and degree? I need to repeat it again. Okay. Okay. You use your calculator, right? You use your calculator. 10 divided with AI alpha AI, you time with 1 plus 0.2 AI, you time with 1 plus 0.05 AI. Okay, then you calculate. Okay, so how can we find the magnitude for the infinity? Then you put it around 19,000, right? Then you calculate, you press the enter. Okay, so you can see that this one is power of minus 12, right? That means the magnitude is 0. Okay, so the magnitude is 0. Can you get it? Minus 12. Okay, and then the base angle is 90. Okay, plus 90 tu, you can see that plus 90, that means 90 you need to minus with 360. That's why you will got it minus 270. Okay, good. Kamaro has it, good. You ask. Oh, sir, understand, sir. Okay, good. Thank you. Okay. Alright. Another question? Ada lagi apa soalan? Tak ada? Okay. Yeah, can I proceed, right? Okay, alright. So we have drawn the Nyquist diagram on the polar plot. However, how we going to see whether our Nyquist diagram is stable or not, or our system is stable or not? Okay, there is some rules there. The stability can be obtained from of Nyquist diagram or the frequency response of the open loop KGH. Okay, right now we draw our Nyquist diagram based on the KGH, right? Open loop transfer function. So as the frequency varies from omega equal to 0 to omega equal to infinity, the condition are as follow. If the gain, right, plus kGH is less than 1, actually, how can you get it less than 1 equal to 1? Do you remember this equation, right? So what did the equation? This is characteristic equation. Characteristic equation that will give you the picture of your what we call it response, right? Response or your system or dynamic response. Okay. So now KGH is equal to -1, right? When we move 1 to here, okay, and then we can find the magnitude. Magnitude KGH is equal to 1, right? Okay, magnitude 1 lah. Okay, equal to 1. So magnitude KGH equal to 1. Okay, so this one we can use it to see whether our system is stable or not. Okay. If the magnitude KGH is less than 1, that means your system is stable. Okay, I will draw it. Okay, let's see. Okay, this is your Nyquist diagram. Okay, this is your Nyquist diagram, and at the 100 degree. Okay, right. So, then the magnitude, the gain, right? 0 to 1, right? So if your Nyquist diagram here, 180 is located at this one, the left, right? So 0 until 1, for example. Okay, okay. So if you got it, your Nyquist diagram, right? For example, like this one. This is your Nyquist diagram, right? So this point that cross to 180 degree, this point, okay, right? If this point is less than 1, right, this length is less than 1, that means we can say that, yeah, our system is stable. Okay, right. So let's say I put it is x1. If x1 is less than 1, so our system is stable. All right. And if you got it, is the Nyquist diagram like this one. Okay, so this point, right, the line in this one, this line, so I put it is x2. So if x2 is more than 1, that means your system is not stable. Okay, and if you got it, your Nyquist diagram that cross at 1, so we can say that, yep, this one is imaginary stable or critically stable. Okay, boleh nampak tak? Okay, alright. And then from that one, we also can know that degree of stability or relatively stability. So degree of stability can be measured by using the gain margin and the phase margin. Okay, the word is gain margin and phase margin. For stable system, the locus or open loop system KGH must be at the right hand side of point -1. Okay, right? That means at the right hand side. Okay, the x1 it will be stable. The gain margin is defined the mutual of the gain of the open loop transfer function KGH at frequency in which the phase shift open loop is -180. Yep, this one. This will be the gain margin. Okay. the base margin is defined as 180 plus with the phase shift or the open loop system kGH at the frequency, and with the gain and open loop system is unity. Okay, right, so let me draw this. After this we will look this example. Okay, right. Okay, this is your Nyquist diagram. 0 and this is 1 and this is 180. 180 here. Okay, then you got it Nyquist diagram like this one. Okay, right, so this point. Okay, so in order to find the gain margin, this is the magnitude, we call it is X. Okay, and gain margin is a GM equal to 1 over X. Right, okay, so you got it is the gain margin here, right, where your X is means the magnitude, right, when your kGH, right, equal to minus 80 degree. This is the definition. Okay, right, okay, so kGH done. And then how can we know the phase margin from the graph? Okay, from the graph, how can we know it? So we need to bring in the 1 here, right? Because 1 will have you a circle, right? 1. Okay, so the point that 1 attached here, right? Then you need to make it line here. Okay, so this will be your phase margin, which is alpha. Okay, all right, so this is will be your alpha you want to get. Or in terms of mathematical model is alpha equal to 180 degree plus p. Okay, so 180 degree plus with kGH, the magnitude, where the magnitude is kGH equal to 1. Okay, so for this kind of question, we will do it mathematically. We will see that we can get the alpha value from the graph and we can compare it with the mathematically after this. Okay, so you can double check it, right? Okay, so the point is, in order to find the gain margin, you need to find this length, and gain margin is 1 divided with this length. Okay, and the phase shift from the graph, you can get it when you draw a 1 here. Okay, you draw a circle 1 here, right? Then you can cross it. So this one will give you a value, for example 160. So your alpha is 180 minus 160 is 20 degree, for example, like that one. Okay, right. This is in term of theoretical. Do you have any question? Faham tak? Faham tak yang saya terangkan ni? Susah betul nak ajar online ni.
Faham.
Faham Okay, let's look example. Let's look example. How can we apply this? Okay, right. So there are two methods lah. That means you can get it from the graph, and also you can calculate it by using mathematical. Okay. Alright. Okay. So example 5.3 here. Now you got it. This kind. 5.3 here. First, kGH. Find the kGH first. 10 as 1 plus 0.1 s squared. Alright. So of course this one we time you by 1 because k equal to 1 and h equal to 1. Okay. Alright. Okay. Let me make it here. And then after that you need to find out the Tmax and Tmin here. 10 S 1 plus 0.1 S times 1 plus 0.1 S, right? So of course you only got it only T. We can say that T means okay, T max 0.1. Then you can find the omega means. So 1 divided with 0.1 is equal to 10, right? Okay, 10. All right. Okay. Then you got it is omega. So we're going to plot omega and kgh, the magnitude, and also the base, and this one the base area. Okay. All right. Then you got it 0 until the infinity, and then you can apply by using your calculator. So you got it this kind of value. Then infinity here 3.058, 1.6 here, 0.5, and 0.1 here, and this one real 90 degree, 1 2 3 degree, yeah, 23 degree, 143, 140 degree, 180 degree, and 216 degree. Okay, so I think you already know how to use the calculator lah. Okay, done. And then after that we draw the Nyquist diagram. Okay, so I just show you lah this one. Malas nak draw. Okay, right. Okay, right. So first, how to find the gain margin, right? So you need to look at this one. Okay, when you draw it, right? Okay, right. Are you going to draw? Ada nak lukis ke? Nak lukis ke tak? Tak perlulah If you want to draw, it's a good thing for you, right? If you don't want to draw, so you can look at this concept lah. Okay, right. So let's say you have draw your Nyquist diagram and then you got it like this one. Okay, you got it like this one. Okay, first of all, how to find the gain margin is you need to look at the 180 degree angle, right? So this one, this line. Okay, this line. All right. Then you need to calculate the length between 0 until this one, right? If we cross this one. When you calculate it, right, you got it is x equal to 0.525, right? Okay, you got it here. Okay, and the gain margin is 1 over 0.525. Okay, right? So that is the gain margin. So far, do you have any question? Ada apa soalan tak? Okay.
No, sir.
Alright, good. So that's the gain margin. Okay. However, sometimes if you are lucky, you can get it your gain margin from your table. Okay, let's see. This is your table, right? We want to look at the minus 180 degree. So how many the gain or the magnitude, right, for minus 180 degree? 0.5, right? Okay, so that means your x is equal to 0.5. Betul? Betul? Betul kan? Okay, so your gain margin is 1 over, that means 1 over 0.5. So your gain margin is equal to 2. Alright. And then what we call it, how to find the alpha. Alpha, that means you need to find the magnitude of 1. So that means magnitude of 1, 0.75, that means 1, Sorry guys, can you give me a minute? I need to take, get it the item from Lazada. All right. Sorry. Okay. All right. Sorry guys. All right. So alpha. Right. How to find the alpha? You need to have the magnitude of one here. Okay. Let's find out the step of one. So 1 minus 0.75 divided with 0.0375 is almost 7 step here. So you can find it 1, 2, 3, 4, 5, 7. Okay. Now you bring this one magnitude, you bring it until it cross your Nyquist diagram here. Yeah, this one, right? And then after that you cross your line here, right? You try to find the angle, cross it, and then you found out is the angle is 155. So how much value of alpha? That's mean 180. You minus with 155, then you get it is 25 degree. Okay. Faham tak? Faham tak? Okay, boleh?
Boleh sir.
Okay, boleh
Boleh, sir.
Okay. So maybe I can repeat a little bit. Okay. Let's say you got it is this graph. Okay. And then the one maybe is this is the one. Okay. 0 to 1. So you bring it here, 1, 1, yeah. Yep, it cross is this one. Okay. So I can zoom a little bit. Susah betul lah. This is our first time teach online class for this subject and how to draw the graph. Okay. Then what you can do is you need to have your ruler, you cross it here, cross it until here. Okay. Then you find out what is the angle for this one. For example, 159. Okay. Right. So this is your 180. So in order to find the alpha that's mean this one, the magnitude. This is the alpha from the 180. So equal to 180 minus with 159 degree. Right? How much is it? 21. Okay, 21 degree. Okay? Right. Boleh? Yeah. So for the gain margin, you need to find this length. Okay, this is x equal to 0.5. So for the gain margin is equal to 1 over x. Okay, you got it. How much is it? 2, right? Okay. Okay. Boleh? Ada apa soalan? Ada? Do you have any question? No?
Ada rasanya sir.
Okay. So this you can get it gain margin and alpha from the graph. Okay, from the graph. So let's see how can we get it from mathematical. Okay, mathematical. Okay. Okay, so and then we can compare it, the value that we got it here. Okay. In order to get it in terms of mathematical, so you need to remember the formula. Okay, x equal to kgh, right, for the x, and in order to get it and square root divided with this one, uh, omega squared square root time with 1 squared plus 0.1 squared omega squared, and 1 plus 0.1 squared omega squared here. Then you got it 10 omega, so 1 plus 0.1 squared omega squared here. And why? Oh, okay, good. Okay, so this one equal to 3 because you expand it, right? Okay, done. So maybe we can expand it 10 omega plus 0.1 squared omega cube. Okay, done. And then base angle, base angle here, or I can put it as base angle kgh here. So base angle, that's mean you don't have 0, you only have pole, so minus tangent it here, omega divided with 0, right? Omega to 0, and minus tangent again, minus tangent again, 0.1, omega divided with 1, and minus tangent again, 0.1 divided with 1. Okay, then you got it is here minus 90 degree, right? Omega over 0, that means the graph will be this point, this point, this point, right? So 90 degree here, right? So because there is minus, and then minus 2 inverse tangent 0.1 omega. Okay, by kgh, right? And also get it this one. Okay, this part, do you have any question? Ada persoalan tak? Faham kan? Okay, do you have any question this one? Can I proceed? Okay, alright. Okay, good. So now we're going to this one, this part. Okay, so in order to find the x, so we need to find this one first. Then what do we have? We have here is p equal to minus 90 degree minus 2 inverse tangent 0.1 omega. Okay, so what you can find out is here this one equal to minus 180, that means this one 180 degree minus 90 degree 2 inverse tangent 0.1 w. So we're going to find the w. Okay, and then after you minus NZT plus with 90 degree, right? Maybe you can find it 2 inverse tangent 0.1 W, and then you got it is my plus 19, and then 0.1 45 degree, and then find it, you can find omega here. You got it is 10. Okay, 10 radian per second. Done. All right, and then after that, after the second step, then you can solve this one. Okay, so we already got it is kgh equal to 10 divided with omega plus 0.1 squared omega cube. Okay, alright, so kgh omega equal to 10 plus 0.1 squared and 10 power of 3. Then you got it is 0.5 here. Right? So that means your x equal to kgh cube. Done. Then you can find your gain margin equal to 1 over x. Okay, 1 over 0.5 is equal to 2. Alright. So this using the mathematically. Okay. So that is the step is you need to apply 180 degree to the equation of the phase shift or this angle, right? Then you can get it the omega, and then after that you apply this value to the equation of kgh, the magnitude of kgh. So you apply here W and W, and then you can get it 0.5 here, and then you can find the gain margin. Okay, so you can double check the value that you got it and the value that you can get it from the graph. It is same. It will give you the same value. Okay. Do you have any question? This one? No. Okay. Let's proceed. The last one. Okay, the last one. So how to find the phase shift mathematically, right? So we already found our gain margin. So the phase shift. So phase shift, the definition is 180 degree plus this one. That's mean 180 degree plus with the angle kgh, where the magnitude is equal to 1. Okay. The concept is you try to solve this one first, right? And then after that you apply to this formula. Okay, right. So kgh, the magnitude, we got it is 10 omega plus with 0.1 squared and omega cube, and replace kgh equal to 1 here, 1, 10 omega plus 0.1 squared cube, right? Then you solve it, you got it is you got it 3 value of omega, 6.82 minus 3.41 minus 3.41. Okay, so I think you can solve it by using your calculator, right? This is power of 3. Okay, so you can solve it by using your calculator. We got it 2 roots, right, here. And then of course we choose this one because the omega is between 0 to infinity. Okay, done. And then we already got it, the omega, we apply to this equation for the magnitude, kgh, the 90 degree minus is 2 inverse tangent 0.1 omega. So you replace this omega, right, with this value. Okay. Then when you replace it, you got it is minus 3, 2 inverse tangent 0.1, you time with 6.82. Then you got it is 20 minus 158.6 degree. Okay, done. Then in order to find the alpha, 180 degree plus with p, that's mean minus 158.6 degree. Then we got it is 21.6 degree. Okay. Alright, I repeat it again. First of all, you apply 1 to the equation of kgh, the magnetic kgh. So for this equation, right? Then you apply this one equal to 1. Then you find out the W. Okay. After you find out the W, you apply to the equation of the phase, right? Phase shift kgh. So this is the equation. Okay. Now you apply the W here. Okay. Go to 6.82. Then after that, you apply, you got it the angle, done. And then you 180 plus with that angle, 180 plus with minus 158.6 degree. Then you can get it alpha. Alright. So it will give you the same value with that value you can get it from the graph. Okay. Clear? Alright. Do you have any question? Alright. Ada apa-apa soalan? Okay. Alright. Oh, Ain Akilah tiba-tiba muncul bila nak habis kelas dah Alright. Done. So I think that's it for our class for today. So what we have learned so far, we have learned on how to plot the Nike diagram on the polar plot. Right, from that one we can see that our system is stable or not. Right, so if your Nike diagram is less than 1, that means your system is stable. And how much the stability of your system. So we can look at from here. Okay, as a guideline, right, the closed loop system have an adequate damping if the gain margin and the phase margin is between less than 3 and more than 2, and the phase margin is 60 degree and more than 40 degree, right? So that means it will give you, you have enough damping ratio and enough the gain margin. So I think we already know before the damping ratio, it will give you the effect of the overshoot, right? The effect of overshoot, right? So that is mean the damping ratio. Okay, all right. So if you got it, the gain margin less than 3 or more than 2, that means it will give you an adequate of damping, right? Okay, so this is the guideline lah, right? Good. Right, and then after that we also calculate the gain margin and the phase margin using the mathematically, and then we can compare with the value that we got in front graph. Okay, so I think that's it for our class. So thank you for your attendance. I will see you again